Greenland is melting right now, and when it fully collapses, the Atlantic Ocean, as we know it, will fundamentally change. But here's the terrifying part nobody talks about. The disruption has already started, and most of the world has no idea what's coming. By the end of this video, you'll understand why Greenland's ice sheet is the sleeping giant of climate catastrophe and why the timeline for disaster might be shorter than anyone wants to admit. You've been told climate change is gradual, a slow burn, something future generations will deal with. That's the comfortable lie, because right now, Greenland holds enough frozen water to raise global sea levels by over 7 meters. That's nearly 24 feet, enough to erase Miami, Amsterdam, Bangkok, and entire island nations from the map. But sea level rise isn't even the most immediate threat. The real danger is what happens when all that fresh water floods into the North Atlantic and shuts down the ocean currents that regulate the climate of nearly half the planet. Let's start with what most people miss. Greenland isn't just ice sitting on land. It's a massive frozen reservoir sitting on top of an island roughly the size of Mexico, covered by an ice sheet up to 3 kilometers thick in places. That's almost 2 miles of solid ice pressing down on bedrock, and it's disappearing faster than scientists predicted even a decade ago. Recent satellite data shows Greenland is losing approximately 280 billion tons of ice every single year. To put that in perspective, that's enough water to fill more than 100 million Olympic swimming pools annually, and the rate is accelerating. Now here's where it gets dangerous. That melting ice doesn't just raise sea levels, it fundamentally disrupts something called the Atlantic Meridional Overturning Circulation, or AMOC for short. Think of AMOC as a massive conveyor belt of ocean water that moves warm water from the tropics northward along the surface, then sends cold, dense, salty water back south along the ocean floor. This circulation is what keeps Europe's climate relatively mild, despite being at the same latitude as frozen Canada. It's what regulates rainfall in Africa and Asia. It's what moderates hurricane patterns in the Atlantic. And Greenland's meltwater is actively sabotaging it. Here's how the disruption works. And this is critical. When Greenland's ice melts, it dumps massive amounts of fresh water into the North Atlantic. Fresh water is less dense than salt water, so it doesn't sink. Instead, it sits on the surface like a cap, preventing the normal sinking of cold, dense water that drives the entire AMOC system. Scientists call this freshwater forcing, and it's the exact mechanism that triggered rapid climate shifts in Earth's past. During the Younger Dryas period, roughly 12,800 years ago, a sudden influx of glacial meltwater into the North Atlantic caused temperatures in Europe to plummet by more than 10 degrees Celsius in less than a decade. Cities that are temperate today were under ice. And that shift happened in a geological eye blink. The terrifying question is, could it happen again? And the answer, according to recent research, is not just yes, but it might already be starting. Studies published in the past 5 years show the AMOC has weakened by approximately 15% since the mid-20th century. That's the weakest it's been in over 1,000 years. Some climate models suggest we could see a critical slowdown or even a temporary shutdown within this century. And unlike the gradual warming most people imagine, an AMOC collapse would trigger abrupt, catastrophic changes that could unfold within a single human lifetime. Let me paint you a picture of what that actually means. If the AMOC significantly weakens or stops, Europe doesn't gradually warm with the rest of the planet. It freezes. London, Paris, Berlin could see winters that rival Siberia. Meanwhile, the tropics would get even hotter, shifting rainfall patterns and collapsing agriculture across Africa and South America. The entire east coast of the United States would face accelerated sea level rise, potentially adding an extra meter of water beyond global averages within decades. Hurricane patterns would shift, becoming more unpredictable and potentially more intense. And global fisheries, which depend on nutrient circulation driven by ocean currents, would collapse in regions that feed billions of people. Now, you might be thinking, surely governments are preparing for this, right? Here's the uncomfortable truth. They're not. Not really. Most climate adaptation plans focus on gradual sea level rise and warming temperatures. Almost none account for the possibility of abrupt ocean current disruption. The economic models used by the World Bank, the UN, and national governments generally assume smooth, predictable changes spread over a century or more. They don't model the scenario where Greenland's ice sheet crosses a tipping point and triggers a cascade of rapid changes within 20 to 30 years. And that's the scenario scientists are increasingly worried about. If you're enjoying this deep dive into geography and hidden global risks, consider subscribing. We cover the maps, science, and geopolitics that shape our world in ways most news never explains. Here's what makes Greenland's situation uniquely dangerous. And this is the part people miss. The ice sheet isn't melting uniformly. It's melting from multiple angles simultaneously, and each mechanism reinforces the others in what scientists call positive feedback loops. Surface melting creates rivers and lakes on top of the ice that drain down through cracks called moulins, lubricating the base of the ice sheet and causing it to slide toward the ocean faster. Warming ocean water is eating away at massive outlet glaciers from below, thinning them from the bottom up. And as the ice surface lowers in elevation, it exposes the ice to warmer air temperatures at lower altitudes, accelerating surface melt even more. One glacier in particular tells the story. Jakobshavn Glacier, on Greenland's west coast, is one of the fastest-moving glaciers in the world. It drains roughly 6.5% of the entire Greenland ice sheet. For decades, it was relatively stable. Then, starting in the late 1990s, it began accelerating dramatically. Between 2005 and 2015, it roughly doubled its flow speed, dumping ice into the ocean at unprecedented rates. Scientists watched in real time as a glacier that had been stable for thousands of years essentially switched into a new, much faster mode of collapse. And it hasn't switched back. Now multiply that scenario across dozens of glaciers around Greenland's coast. Each one is a potential trigger for accelerated ice loss. And here's the nightmare scenario that keeps glaciologists up at night. If enough of these outlet glaciers destabilize simultaneously, they could trigger what's called marine ice sheet instability, SEET. This is when ice sitting below sea level becomes unstable and collapses in a runaway process that, once started, might be impossible to stop with current technology. Parts of Greenland's ice sheet sit in bedrock basins below sea level, making them vulnerable to exactly this kind of collapse. The geopolitical implications are staggering, and almost nobody is talking about them. As Greenland's ice melts, it doesn't just threaten distant coastlines, it's opening up the island itself. Retreating ice is exposing land that hasn't seen sunlight in millennia, land that contains some of the world's largest untapped deposits of rare earth elements, uranium, and other strategic minerals. Countries including China, the United States, Russia, and European nations are already positioning themselves to exploit these resources. Greenland, which has a population of only about 56,000 people, suddenly finds itself at the center of a new Arctic resource scramble. Denmark technically still governs Greenland, though the island has broad autonomy. But there are serious questions about whether that arrangement will hold as the stakes increase. In recent years, there have been proposals floated by the United States to purchase Greenland, offers that Denmark rejected, but that revealed the strategic thinking at play. Meanwhile, China has been investing heavily in Greenland's mining sector, building infrastructure and relationships that worry Western military planners. Because here's the thing, Greenland isn't just about resources, it's about geography. As Arctic sea ice retreats, new shipping routes are opening up that could cut weeks off transit times between Europe and Asia. And Greenland sits right in the middle of those routes, along with hosting Thule Air Base, one of the United States' most strategic military installations. So you have a melting ice sheet that threatens global ocean circulation, rising geopolitical tensions over newly accessible resources, and indigenous populations who've lived there for thousands of years, watching their entire world transform within a single generation. The human element gets lost in the big climate numbers, but it shouldn't. Greenlandic communities built around fishing and traditional hunting are seeing species migrate away as ocean temperatures change. Towns built on permafrost are watching buildings tilt and crack as the ground beneath them thaws. And unlike wealthier nations that can afford massive infrastructure investments, Greenland's small population and economy make adaptation extraordinarily difficult. Let's zoom out for a moment and look at the timeline, because this is where myth and reality diverge sharply. You've probably heard that climate change effects will be felt mainly by our grandchildren. That's outdated thinking. The effects are here now, and the acceleration is real. In 2012, Greenland experienced a record melt event where surface melting was detected across 97% of the ice sheet's area, including at the highest, coldest elevations. That was supposed to be a once-in-a-century event, but similar extreme melt events have happened multiple times since. The so-called 100-year events are now happening every few years. Ice core data tells us that in the past, when Greenland's ice sheet retreated significantly, it didn't take thousands of years. It took centuries, sometimes less. We're not talking about a slow fade. We're talking about the potential for dramatic, civilization-altering changes within the lifetimes of people alive today. And here's the brutal part. Even if we somehow stopped all greenhouse gas emissions tomorrow, Greenland's ice sheet has already absorbed enough heat that significant additional melting is now locked in. The question isn't whether it will continue melting. The question is how fast, and whether we cross the point where the collapse becomes self-sustaining. Some scientists argue we may have already crossed critical thresholds. Others believe we still have a narrow window to act, but almost everyone agrees on this. The next 2 to 3 decades are absolutely crucial. What we do or don't do about emissions, about Arctic governance, about adaptation planning in this critical window will determine whether we face a manageable crisis or a catastrophic restructuring of global climate and geopolitics. The most unsettling part of this entire story is the uncertainty. We know the Greenland ice sheet is melting. We know that meltwater is already affecting ocean circulation. We know the potential consequences are severe, but we don't know exactly when critical tipping points will be crossed or how fast changes will unfold once they start. We're essentially conducting an uncontrolled experiment on the planet's climate system, and Greenland is one of the main variables we're manipulating without fully understanding the equation. This matters globally in ways that go far beyond environmental concerns. The stability of the Atlantic Ocean's circulation affects global food security, economic stability, and geopolitical power balances. A Europe plunged into severe cold, while tropical regions become uninhabitable, would trigger migration patterns that make recent refugee crises look small by comparison. Coastal megacities housing hundreds of millions of people would face existential flooding threats. The economic damage would be measured not in billions, but in tens of trillions of dollars. And it all traces back to this massive island covered in ice that most people rarely think about. So what can actually be done? The honest answer is, we don't have good solutions yet. Some scientists have proposed radical geoengineering schemes, like building massive underwater curtains to block warm water from reaching glacier fronts, or even attempting to refreeze parts of the Arctic using artificial snow. These ideas range from barely feasible to pure science fiction, and all carry massive unknown risks. The only proven strategy is the one we're not implementing fast enough, drastically reducing greenhouse gas emissions to limit further warming. But here's what you need to understand. Greenland's disruption of the Atlantic Ocean isn't a future possibility. It's a present reality unfolding in slow motion until suddenly it's not slow anymore. The fresh water pouring off that ice sheet is already in the North Atlantic. The currents are already weakening. The feedback loops are already engaged. We're not looking at a switch that hasn't been flipped yet. We're looking at a process that's already in motion. And the critical question is whether we can slow it down before it becomes unstoppable. If this video changed how you think about Greenland and ocean currents, hit that subscribe button and drop a like. And here's a question for the comments. Do you think governments will take action before we reach a tipping point? Or are we already past the point of preventing major disruption? Leave your honest thoughts below. And if you want to dive deeper into the science and geopolitics of Arctic change, check out the resources linked in the description. The Atlantic Ocean's future is being written right now in Greenland's melting ice, and what happens next affects every single person on this planet.